So our timing here gives us, basically 3 days to get a little bit of review for next week's check-in. On the check-in, each time for your math check-ins, they cover 5 standards. Each standard usually has 5 questions to it. Okay, so 5 for each topic here. Obviously, those numbers, those mean nothing to y'all. But what that means, we got on this test, we got equations and inequalities. Y'all, that's like back probably September still at that point. That was our cluster C stuff. So we were probably still doing those back in September. So it's been a little while. Then F3 is where you got to identify if a function's linear or nonlinear. When it's graphed, that's pretty easy. You got either a straight line or a curved line, right? We got some other stuff with that too, though. F4 is working with linear functions. That's where you got to find the slope or y-intercept or both, like find the whole function kind of thing. F5, I never really know what to call those. Those like scenario graphs where it's like, I don't know. Taquan was walking to school. He stopped and sat on the bench. Then he realized he was late, so he ran the rest of the way. And it like has like a line, goes flat, then a steeper line kind of thing. Those kinds of graphs. And then G5 there is angles. All right. So that's working with the interior, exterior angles on triangles. That's also working with like the parallel lines with the transversals. So pretty big range of stuff. And, some of it goes back to a fairly long time ago, right? All right, so let's start with this. We got an equation here. With Desmos, if this is on the calculator active, what you would do, you put that into one line. You got to change it to X, though. Remember, we got to use X or Y with Desmos. And you put that in to another line. So you put it in as 2 separate equations. You're finding where it crosses. The answer is your X value, right? So that's how you can do that with a calculator. So if it's calculator active, and sometimes equations are, that's all you need to do. Equations, though, probably going to be what? Probably inactive? Yeah, so when I solve this then, if I work this out, what do I have to do first? The parentheses, I got to distribute. And when you distribute, you got to pay attention to signs. That's a -2 I'm distributing, okay? So I got 8 minus 2n, and then it's -6. We got to distribute to both parts. We're multiplying each part. On the other side, there was nothing to distribute, so we got that. All right, now what? What's the second step? The like terms. It's not moving the variables from one side. That'll be next. But we got to do the like terms that are on the same side of the equal sign. So here I got 8 minus 6. 8 minus 6 is 2. Still got the -2n. All right. On this side, I got n and a -3n. Remember, when it's just a variable by itself, it's like there's a 1 there, right? Signs are different. We subtract. Use the sign of the bigger number. I don't know why it changed to red, but we got -2n, and then we got +7. All right, so now what? We got to switch their sides, right? We got to get the variables all on one side. So which one of those should I move? So they're the same ones, right? We got a -2n and we got a -2n. So Corey, what's that mean? You were just saying you were on the right track at least. So look, y'all remember, if the coefficients are the same, infinite solution or No solution, okay? So we're looking at an infinite or no solution problem here. Everybody good with that? Anybody remember how to tell the difference between an infinite or a no solution without using Desmos? Both lines are on top of each other, so if we graphed them, that's what we would see. Without graphing them, just looking at it like this, though, I mean, you're right.
The n numbers be the same, like the coefficients and...
All right, so if it's infinite, if it was infinite, everything has to be the same. Since there are two lines on top of each other, they have to have everything the same. No solution, they have the same slope, or, on equations like this, the same coefficients, different constants. Since this has different constants, this would make this a no solution. Any questions there? Yeah, you just follow your steps, right? Sometimes, or occasionally, we're getting those. So kind of along the same lines. I've got an equation here. Now, this isn't probably how a question would look on your check-in, but it's covering like that same stuff. So we need values for A and B that would make that so it has one solution. Give me an example for A and B. Like, what could A equal to give me one solution there? 1 and B. That'll work. She said A equals 1, B equals 2. All right. If I plugged those in, I'd have 2x plus 1 equals 5 minus 2x. That would have one solution. When it has one solution, what you have are different coefficients. Different signs mean they're different, right? We need this to have no solution. So who can give me a value for A and B to make it have no solution? No. For that first one, you almost could have picked like almost anything. For this one, A doesn't matter as much, but the B has to be something. Jaquan? Okay. That'll work. -1, -2. B has to be -2 because if I have 2x, and I'll just go ahead and change that to -1 for the -1, and then it equals 5 minus -2x, because we had minus b, right? When I got minus and negative, what do? We do same change, right? So that becomes plus that positive, so now the 2x's match. Everybody kind of follow on that? All right, so then for infinite solutions, what would A and B have to equal? No. This is the one we need an exact number for both A and B. All right, so A is the constant. For infinite solution, the constants have to match, right? What's the constant on the other side? What's the constant on the right side? 5. So that means A has to be 5. B is the coefficient. The coefficients have to match. So it's just like the last one. It's got to be -2. So we'd have 2x plus 5 equals -2x, which, like we said, changes. So that makes everything match. Everybody kind of follow? Like I said, those are just kind of worded a little differently than you might see. But usually with infinite or no solution, it's like a drag and drop type problems. We'll do some more of those probably tomorrow or next week. All right, this isn't multiple choice. I just put like 4 parts to it. We're looking to see if it's linear or nonlinear. Okay? So let's look at anybody think they can tell me if it's linear or nonlinear? All right. This one is nonlinear. It has an exponent. Exponents make them nonlinear. All right, what about B? You can tell me on B. Linear. All we have is just like regular variables. Okay, if we just have regular variables, that's going to make it linear. All right, C. Jaden? Nonlinear, because when I distribute, I'm going to have x times x. X times x is x squared, so that makes it nonlinear. D, the graph's probably a little bit easier. Hunter? Huh? Oh, no. Eric? Nonlinear. Why? It's curved. If I play connect the dots, there, that's a curved line, isn't it? Linear needs to be a straight line. Curved. All right. Everybody kind of follow on that? Like I said, we'll go over those a bit more, get a little more repetitions with it. But basically, if you see or variable times variable in an equation, that's nonlinear. Like I said, graphs, curved lines versus straight lines on that one. All right, so we have to get the functions a couple different ways. So I get my slope-intercept form function, my y equals mx plus b. All right, so how many of those points do I need to use? I need to use 2 of them, okay? Doesn't matter which 2. So definitely want to use that one. 0 is easy to work with. 2 is easy to work with. Not bad. I'm just going to use this one because 1s are going to be easier than 2 and 8. And each one of them had a negative somewhere, okay? So we got to do 2 things. We got to find our slope, then we got to find our y-intercept. Sometimes the problem asks you just for slope, sometimes it asks you just for y-intercept, sometimes it asks you for the whole equation, okay? So how do we find slope? Rise over run, that's good for a graph. We use different words with the ordered pairs. Change in y over change in x. So my y values are going from 2 to negative 1. My x values are going from 0 to 1. So 2 to negative 1, how much does that change? 3. What direction? Up or down? Down. Since it's decreasing, we make it a negative. 0 to 1, just going up 1. Negative 3 over 1 is just negative 3. That's my slope. So m is negative 3. All right? Now, how do I find y-intercept? Marcos? Y minus mx, right? Y'all remember doing that? A lot, right? Y'all, which point should we use? Probably. Probably the one with 0, right? 0 is going to be easy. So my y value is 2 minus negative 3 times my x value. You got to do multiplication first. So what's negative 3 times 0? 0. What's 2 minus 0? 2. So that means my b, my y-intercept is 2. Y'all, the y-intercept is when the x value is 0. That was the y-intercept right there, 0, 2. But, you know, we still have to find the steps on another problem. So if we had to write the whole equation, that's where we do y equals mx plus b, m, slope, x, plus y-intercept, 2. Any questions on that? We at least remember that a little bit, right? That was probably like, Thanksgiving, Christmas time, working on those. All right, so then we got to do it for a graph too. All right, so graphs, y-intercept, hopefully should be the easy part. The y-intercept is where the line crosses the y-axis. This graph, this picture looks a little different than some graphs you'll see, but where is it crossing the y-axis? What number? 0, 4, so what's our y-intercept? What number? 4, the y value. So there's our y-intercept. Y-intercept's 4. So I'm going to have y equals something x, and I got plus 4. All right, now what do we do? Jacob, how do I find slope? Rise over run. Rise over run, it's doing the exact same thing. It's changing y over changing x. But, rise and run, a little easier when you're counting on the graph. So my rise, my run. How many did I go up? 1 over 4. So, y'all, is that a positive or negative slope? Positive. Why is it positive? It's going up. As I move from left to right, it's getting higher. There's my function. Again, not so bad, right? All right, so here's one of those scenarios. I'm just going to school. What's happening? It's waiting on the bus to come. They're standing still. Bus stops, and E, and keep going again, right? Everybody kind of follow on that? These aren't like saying. When he walked, we had a flatter line than when the bus goes. Hopefully, your school bus is going faster than the walk, right? So that should have a steeper line because its speed is increasing. The slope's kind of the speed on these problems. And then when it stops, it's not moving. It's a flat line. That's a 0 slope. Then we got angles. We got to find x on this one. Where's x? Inside or outside the triangle? Outside. So when it's on the outside with exterior angle, we got to find the angle next to it first. So first we got to find that. Okay? What do the 3 angles on a triangle add up to? 180. So if I start with 180 and I subtract what I know, what's left will give me that question mark, right? So what are the 2 angles I know? All right, we got 40. So that's 140 when I subtract, and then it's 90. Remember the little square is 90, right? So minus 90. What that gives me is 50 right there. Now, what do those 2 angles add up to? The inside and the outside, the interior, exterior. 180 again. You remember, we use 180 a lot on these, right? So if they add up to 180, we just start with 180, do an opposite. That's a plus 50, so we do a minus 50. And that means x equals 130. Okay? Remember those? The other thing with angles, we have our transversals, where we have the 2 parallel lines. This one looks a little weird because it's not like the 2 parallel lines, but if I would have kept this line going, then we would have 2 parallel lines, right? So it still kind of works out the same. The green line there just so it shows a little better. We're looking for A and B. We got two things we got to find here. What do those three add up to? 180. It makes a straight line, right? Anytime you got a straight line, the sum of the angles has to be 180. So we got 180 minus 50 minus 45. So what that gives me is B is 85. Everybody good with that? All right. So then, what do those three angles add up to? 180. Yeah, like I said, we use 180 a lot for these, right? So we start with 180. I got 180. I'm going to go minus 85 minus 75. 180 minus 85 is 95. 95 minus 75 would be 20. Okay? That was, I don't know, December when we were working on those. All right, so each of those problems are problems that the state of North Carolina has put online that says that's what you're supposed to know with these standards. So I would imagine that's kind of how your check-in is going to look, problems like that. So if you remembered those pretty well, hopefully we'll be doing okay for the check-in.